Hi guys, welcome back, and in this session we'll be actually making our first project using Eagle. Go ahead and launch your Eagle software. It opens with a control panel like this. Now one thing you must learn is to organize your projects in a particular folder. In my case, I have all my folders going into my documents and a folder called Eagle. When I click on the folder, all I have the complete files of a project. So this is how you organize your projects. If you see, we created a my first and I have my my first in this particular location. Care must be taken that whenever you create a new project, it must be saved only in a specified locations and not hitherto anywhere on your system. To begin with our first project, on the control panel, and when you expand your project section, you will see a folder which says Eagle. Expand it further and you have a list of your projects here. You right click on this Eagle folder and it gives you two options. One is to create new folder and the other is to create a new project. We will select create a new project. It gives you an option to create a project. Let's go ahead and name it as voltage divider. Select. Now this gray indication and the green indication, as we've discussed earlier, this green bubble will indicate this is an active project. Now I can click on the project and then I have multiple options. The one which concerns me is this new option here, new function. You select, just hover on new, then say schematic, and it takes me to the schematic window. I can go ahead and make my schematic here. But before that, if you observe, the project reads Eagle voltage divider untitled schematic. Now it is important that when I save a schematic file, which is nothing but a circuit diagram, right from the name of the diagram itself, I should be able to understand what exists in that particular file. Like our standard Word files, you can go ahead, file, save as. Ensure that it is getting saved in your in the Eagle folder itself. It is not getting saved on desktop or some other remote location. We want it associated with your project files. Just make sure your path is clearly highlighted out here. You can browse through it. If you feel that your project folder is somewhere else, make sure you transfer your files onto that folder. Okay, so this is the voltage divider schematic. It takes the extension by itself, so you just have to name it as voltage underscore divider and hit save. Okay, fine, I'm good to go. I have voltage divider, a project folder under which I have the voltage divider schematic file. Now let's begin with creating our schematic. All we need is two resistors, so you select add, go ahead, type resistor, hit enter, and you have the search results here. Look for the resistor library and expand the American symbol, then select 207/10, the 5mm resistor, and select OK. Control and scroll to zoom in and zoom out. Click 1, creates first instance. Left click 1, creates second instance. I need only 2, so I hit escape. Okay, now I need VDD. I'll select supply 1 VDD or maybe supply 2. Okay, then go ahead, select ground. Now let's arrange the components how we want them. Last time we did an ERC, we saw the circuit wasn't complete. It was indicating only single pins connected with VDD and ground. Let's see how we solve those errors this time. So arrange your components in a vertical manner. Let's do it again. Keep this here. Okay. You select the move tool, left click on the component, selects it. I can move it now. Right click, done. Left click, right click. I want ground to be here. Let's zoom in now. Let's make the connections. Select wire tool, left click. You can actually zoom in more. Wire tool selected, left click. One last, left click and left click. Okay, I'm done with connecting. Now I need my output from here, so left click and left click. Okay, now I need to physically provide voltage supply and ground connections to the schematic, so I will make provision for same. Let's take one more wire from here and leave it here as of now. This is going to be our VDD. Now care must be taken that when you want So we will still need to provide VDD and ground, so select your wire tool, click on the middle and just select a wire here. Yes, if you observe, we won't be able to place a wire in between R1, R2 and ground. That's because there is not much space in between the components. So make sure you leave enough space when placing the components. Now we can, yes, okay. Now I have my 3 connections done. Let's use our label tool and name them. So this is going to be my output, okay, this, okay, VDD, it associates, and ground, fine. Now it's not a good practice to leave your nodes open or floating like these. You will actually need to provide some provision when you are going to put the schematic onto a physical board. You will have to give at least 2 pin headers or some physical connection between your supply and your board. So let's see how you can do that. Go to your add tool again and look for pin header. You will have to go ahead, scroll down until you see a pinhead library. Okay, here we have our pinhead library. Click on 1. So this indicates pinhead 1 cross 1. That means it's a single pin. Then you have 1 cross 2. Now you see this is a category. This is my category or the package which is called pin headers or pinheads. Then I have a category or a subcategory which is of the type 1 cross 2. That means 1 column and 2 rows. Then I have 1 cross 3, 1 column, 3 rows. If I expand 1 cross 2 further, I will have 2 more options possible. This is the one which fits vertically onto your board, and this is the one which fits horizontally onto your board. We will use the one which fits vertically, but we don't need 1 cross 2 because we need 3 connections, that is VDD, ground and our output. So expand 1 cross 3 and select the one which fits vertically, or the one which looks like this and not this. We want this particular footprint. Select OK and here OK. Escape, close. Now just observe this pinhead closely. This plus on your right hand side is the component origin, whereas these small lines are where your wires will have to be connected. So let's say when I want to make the output connection, I will take from here and connect it here. I cannot connect it like this. You don't have to connect it inside the circle. You have to just touch these small wires. You don't have to connect it through the circle. So let's VDD. Okay, left click, done. Care must be taken that you don't cross the circle. Your wire must end at the small red line. Okay, done. Now let's do the ERC again. Fine, we have no errors, but we do still have 6 warnings. It says missing junction in net ground. Now if you would have observed, it didn't ask you do you want to merge these or you want to rename these segments. So as of now for Eagle, this ground connection has not been made, so let's secure that. You take the junction tool and place a junction here. Hit ERC again and okay, missing junction is gone. Similarly, you have a missing junction in output. Yes, place a junction here. And similarly, place a junction in VDD. Okay, and run ERC again. Fine. Now it says that JP1 has no value and oops, we did not give any value to R1 and R2. So let's fix that. Let this be 1K and let this also be 1K. Run ERC again. And now it says that JP1 has no value because this component are just 3 pins. They don't have any value as such. These are just simply a pinhead. If we want, we can probably rename this and give as pins. Fine, okay, pins. Now if we do ERC, there are no errors as such. We have just one warning which says that pins have no values. Okay, we are fine with that. When you say that ERC doesn't give you any errors, that means your schematic is complete and you can now go ahead and make your board. Now there are 2 methods to switch from schematic to your layout or the board file. One is you can go to the file tool, file, and then say switch to board, or else on this drop down menu which says sheet under your view menu, there's a small icon which says generate or /switch to board. So using this icon you can switch from your schematic file to a board file, or you can say file switch to board. Both do the same function. So we'll stick to the icon, and it says your board file or the layout doesn't exist. Do you want to create from this particular schematic? We say yes. So you must notice that once you name the schematic, if you derive a board file from that particular schematic, the board file automatically derives its name. Now, care must be taken when you're working with an Eagle project. You must have 3 windows open. One is your control panel for that particular project, schematic window of the project, and the board file of the project. Okay, now let's say I close my schematic file. Now you must be wondering that, okay, fine, I now want to work with the board file. I don't need my schematic open. But no, you cannot work that. You cannot work that. So you will have, let's see what happens when you close the schematic file keeping your board file open. It gives you an error which says forward backward notation has been severed. That means now there is no link between my board file and the schematic file. Any changes that I probably want to make within my board file will not be reflected on my schematic file, whereas changes made on my schematic file won't be reflected on my board file. You must avoid working with a warning like this. It is not going to help. Now, how do I figure out where my schematic is? There are 2 ways. You go to your project folder in the appropriate location, or you can go to your control panel, look for your project folder under the Eagle folder, and click on the schematic file. Okay, this is the schematic file. Click on it. Fine, and then I am good to go. So this is how your board file looks. This white frame is the maximum permitted board size that the light edition will allow. This is physically going to be a very big board size. If you place the mouse pointer here, it's going to be a close to, it shows 3.95 inch by 3.5 inch, which is a very big board size. Let's reduce the board size first. So you can select the move tool and you click at the center of white line and you can move it. You must not click at the corners, that will deviate your board shape. You must only click at the center and simply drag. Avoid dragging from all the 4 sides. Drag only from the top and the right. Once you feel that, okay, fine, this is going to suffice, you can click on this magnifying glass which indicates zoom to fit. Okay, this size is still too big for my schematic, for my board. It's just going to be 3 components, right? So I can further reduce it. Okay, now zoom to fit. Fine, I think this should. Now there is an auto routing option available with Eagle, but that's not what you should do because it's not going to help. It's going to make bigger circuits even more complicated. If you manually route your circuit, you know what is placed where, you know what changes to make, you know what are the test points that you have considered, and there are many more advantages of manual routing, so we will stick to manual routing. Select the move tool, click on the origin and drag your components into the board area, and fine. Now this doesn't finish the job. If you see, there are wire indications which are indicated by these yellow lines. These come from these green lines in your schematic. Now let's say if I delete the VDD connection for some time and I observe my board, one connection has gone missing. There was a connection from here to this R1 which has gone missing. So let's say Z. Let's observe again. Okay, great, we have the connection here. Now care must be taken that there are no overlaps or path overlaps in your board file. When I mean path overlaps, that means you are going to overlap 2 conducting wires, or you're going to overlap 2 copper paths, which is not a good idea. In schematic, I can have a wire crossing like this. This won't be considered a overlap. It will be only considered there is some wire crossing over, unless and until I place a junction here. Then it will ask me to merge a segment into net. No. When I merge it, only then it creates a junction or a node, and until and unless it won't. But the case is not the same when you're dealing with the board file. An overlap will short the wires, it will short the components. You don't want to do that. So the very first step of manual routing is to avoid such yellow crisscrosses. If you observe closely, I have a cross here and I have a cross here. So you can use your move tool, rotate your components adjust them better. Fine, I have resolved one cross at least. Okay, similarly let's do it for the other one, and here I'm done. Now you cannot leave it here, you have to place a path on top of these yellow wires. Let's see how to do that. Above your wire tool, you have a tool which reads route tool. If you observe, this tool is enabled only in the board only on the board file and not for the schematic file. Select the route tool, then on the width, then on the formatting bar on the top, you will see an option saying width. On the drop down menu, select 0.24. This is the minimum width that you should be working with. 0.016 mils or 0.016 is going to be a very thin path. It might just ship off in the process. Then there is a tab which reads 16 and bottom. We'll look at that after some time. And then you have multiple options which are angles. You have an obtuse angle and you have a slant line, you have a 90-degree. But these are wire bends. So you shouldn't be working with 90-degree wire bends. You should always be working with an obtuse angled wire band. So select the wire, select the bend style and start connecting. So when you start routing, your wire will appear like this. This is your path. Sorry, not wire, your path. Now observe closely. When I select a node or a junction from where I want to begin connections, the yellow wire is constantly prompting where it has to be connected. If I move it around, even outside the board, it is still prompting where am I supposed to connect this. So the point here is you do not have to blindly follow the yellow lines. You can reroute it and route it from wherever you feel is going to involve less space, because more the space, more is going to be the cost, and longer the route, more is going to be the loss. So here I'll connect it like this, and this indicates a connection done. Similarly, let's do it for the other one now. Okay, now let's say for example this connection is wrong. I want to remove this connection. I cannot simply use the delete tool. It will remove the connection from the schematic file as well. Do not use the delete tool on the board file. If you feel that a route is wrongly placed, next to your route tool you have the rip up tool. You select the rip up tool and click on the path. Then you have your route as it is. Then you use a rat's nest tool which is right above your ERC tool. Here select rat's nest. What rat's nest does is it finds the shortest path possible for every connection in your circuit. Now since this is a smaller circuit and we know that there aren't much complicated connections present, we didn't do it. When you have a bigger one, you must always do rat's nest after the placement is done. So let's go a couple of steps back. Let's rip up the connections and let's move our components around. Okay, I have some path left here. Okay, now just let's move our components around, and I say I place it like this and I do rat's nest. It's going to find the shortest route. We know that there is a common point between these components, so why not place it like this and you have a shorter path possible over here. But we place it here just to make our circuit a little more presentable. So let's move it to our original place and then do rat's nest. Okay, so in this particular arrangement we have the shortest paths achieved. So now we have the shortest paths achieved. You can go ahead and route them. So route tool with 0.024. You have to connect it in the same fashion as you do it with wires. Left click and left click. Okay, so we are done. Now you can still use the show tool and click on the pads. These green circles or the green areas are called as component pads. This is where you will actually be soldering your component leads. Select a pad and see if it's connected. So this had to be connected here. The green highlight will indicate that yes, the connection is achieved. Yes, and okay, yes. Now like we did an ERC with the schematic file, we have a DRC, which is a design rule check with board files. So right next to your ERC tool on the toolbar, you have the DRC option. Click on the tool and it opens a window like this, and then you say check. Okay, wonderful, we have no errors. It is indicated here, DRC, no errors. Let's say while moving, I moved my component not here but it's here. Now let's do DRC again, check, and it is going to give me dimension warnings. That means that my component is too close to the board boundary, and while making the board, this might not just appear, so you have to fix that. Select your move tool, and get it back to inside your board considerably, and then do DRC again, check. Okay, now we have no more errors, so we can go ahead and make this board. Now let's see how to make our project a little more presentable. Let's go back to our schematic file, say zoom to fit. Now let's see how do you add a attribute to this particular schematic file. So this is going to indicate that okay, my file is saved with this name, but when you actually want to send the design across for manufacturing, you need to indicate what is the size and what is the design called, what edition it is, what version it is. For that you have an option in Eagle called as attribute. Right under your junction tool you have an attribute tool. You can use this tool, but before that go to add, and in search find look for frame, and you have multiple frame options possible. So A4 size is going to be good, A3 is going to be too big for our design. Let's say A4 small, but we don't want it portrait, we want it in landscape. Okay, A4 small, A4 LOC, and say okay. Place the frame around your schematic such that it covers it. Just click once, so you have only one instance of the frame created and not multiple instances. Hit escape, cancel. Now I say zoom to fit, fine. It associates with the project file, with the project name, but it says it's not saved. Okay, before adding the attribute, let's just make our schematic presentable. Select the group tool and move it to the center of the frame. Now to add an attribute, on the draw menu select attribute, then go to the view menu and then say redraw. Okay, before doing that you actually have to save your file, so click save first, then go to draw, then select attribute, then select view, and then redraw. Now here it indicates the date and the time when I've created this particular schematic. Now let's go back to our board file. Let's say I want to add a name to this particular design. Let's increase the board size of, then I can use the text tool which is right next to your wire tool. Click on the text tool and enter the text you wish to see on the board. I just want what circuit it is to be indicated, so I will say voltage divider and say okay, and now I can place it. So you can just place it somewhere first, right? So similarly, so as you were doing it for a component, left click, right click is going to rotate, left click is going to place. We might have to actually decrease the font size or increase the board size. Now this font is too big, so we might have to just use a shorter name. Okay, let's call it as PTG divider. Okay, this will be fine, and I can place it here, fine. So this is my voltage divider circuit. I can associate your name, you can give the designer's name, you can give the circuit name, you can even mention the date. So this is it with our first Eagle project. In the next session we'll be looking at a little advanced circuit. We'll see how to make compact circuits then. Until then, thank you.